Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone that are watching my video. In this video, I would like to present about the application of vectors, specifically the application of vectors in computer graphics and visual effects (VFX). Before I continue my presentation, let me introduce myself. My name is Nur Jodisha Bintuma Marizwan, with my registration 20251623100134 from Unit Med 3 PPISMP and supervised by Dr. Shamila Dewi, anak perempuan Davadas, for MTES1104 Algebra. Next, we move to the table of contents. Okay, we have 5 subtopics. The first one is about the introduction to vectors. This subtopic will show about how to understand the magnitude and direction in mathematical quantities. And second, we move to the application of vectors in computer graphics. It's about how vectors power visual effects and 3D rendering. And the third one is the main part, which is the problem statement. The problem statement is about designing an energy shield for superhero movie VFX. The problem statement is contains about a question for 20 marks, and followed by the step-by-step solution. It is a complete calculations for sheet geometry. And lastly, we'll see about the conclusion and references about the real-world applications and some of academic sources that are related with this presentation. Okay, we move to the first subtopic, which is the introduction to vectors. Vectors serve as the fundamental language for translating abstract mathematical concepts into three-dimensional reality. By defining both magnitude and direction, vectors allow us to calculate the exact orientation of surfaces, such as the hexagonal energy shields used in modern cinematography and visual effects. So as we can see, the figure on the right is the simple representation of vectors, which means the general understanding about the vector. Okay, and next, at the heart of this process is the normal vector, a perpendicular line that dictates how light reflects, how objects collides, and how surfaces are rendered by a computer's GPU. So in this presentation, we will see about the specific vector, or which is the normal vector. Okay, it is a perpendicular line, okay, that helps the developer to render in computer's GPU. Okay, and it is understanding the relationship between a fixed point in space and its normal vector is not merely a classroom exercise. It is an essential requirement for precision engineering, architecture modeling, and the optimization of real-time digital environments. Okay, and next we see about the application of vectors in computer graphics and VFX. In computer science, the use of vectors is termed vector graphics. So in computer science, we call the vector as vector graphics, okay, because the vector are used for the developer and designer to create a graphics in computer's GPU. Okay, vector graphics are computer images created using a sequence of commands and mathematical equations and formulas that place lines and shapes in two-dimensional or three-dimensional space. This method ensures that images maintain high quality and sharpness at any size, making them ideal for logos, illustrations, and other designs. So below are the three most used of vectors in computer graphics and VFX. Okay, the first one is normal vectors. Okay, normal vector define the perpendicular direction on planes. Is telling the computers which way surfaces face. So the normal vectors help the computers where are the surfaces facing in some of the direction. And next, collision detection. It is position vectors to update every frame to track object movement through scenes. So in this case, it helps some of the objects for rendering or maybe for CGI It helps for the computer to see where the objects move from one point to another point. Okay, and lastly, physics simulation. It uses Cartesian equations that determine if projectiles intersect with surfaces. So we can see any subject or objects easily intersect with surfaces. So it helps the graphic or the output to make sure that the object is directly on the ground, okay, or the surfaces that the designer wants. When a digital object like a laser or projectile moves through a scene, it is represented as a position vector that updates every frame. To determine if the projectile hits a shield, the computer used the Cartesian equation of the plane ax plus by plus cz equal to d to check if the projectile's coordinates intersect with the shield surface. This mathematical foundation enables realistic lighting, reflections, and physics in visual effects. Okay, next we move to the crucial part, which is the problem statement. Okay, below are the questions. Below are the questions that require 20 marks, okay, to be calculated. Okay, the problem statement is about the energy shield design. So we know some of the game or maybe a movie like Captain America, it have the main character have its own shield. So this is how the designer or the editor to edit and render their character to make it more livable, to make it lively. Okay, visual effects. Okay, next we move to the question. Okay, a visual effects VFX. Artist is designing a shimmering energy shield for a superhero movie. To make the shade reflect light correctly, the computer needs to know exactly where the flat surface of the shade is positioned in the 3D scene. Okay, below are the given information for the question. Okay, the first one is sheet center location. The sheet is located at point A for -2, 3. Okay, and then we have the normal vector, which is the aim vector. The sheet surface must be perpendicular to the direction the hero is pointing. It's represented as n equal to 3, 5, -1. And we have the last given information. General form on shield. Okay, we let P as X, Y, and Z represented any pixel on the surface of the shield. And then we have some required calculation that helps the designer and developer to render their subject. Okay, the first one, we need to write the vector equation for the sheet in the form of n multiplied by r minus r naught equal to 0, and explain why a CGI programmer uses the normal vector to determine how light bounces off the sheet. So from the given information, we need to write the vector equation, okay, in the form of dot product. Okay, this is the dot product, and then we need to explain why the programmer used the normal vector, okay, to determine the light bounces of the sheet. Okay, next, we need to substitute the hero's m vector and the sheet center into scalar form. So from the first vector equation, we need to substitute and transform it into the scalar equation. And then the third one, simplify the equation into the general Cartesian form. This is the formula the GPU graphics card will use to render the shield. So from the second calculation, which is the scalar equation, we need to simplify and transform it into the general Cartesian form, because the GPU or the graphics card use the general Cartesian form to render the shape. They do not use the scalar equation, they use the general Cartesian form. And next, there are CGI spark effect located at Q507. So we need to determine if this spark is actually touching the energy sheet by testing it against your Cartesian equation. So we need to use the Q coordinate to determine whether the spark is actually on the energy sheet or not. Okay, and the last calculation, the artist wants to place a scratch detail on the sheet at horizontal coordinates x equal to 2 and y equal to 1, and calculate the exact z coordinate for this detail. So it's given that x equal to 2 and y equal to 1. So we need to find the z coordinates to help the artist to place a scratch detail, okay, on the subject or on the shield. Okay, this is just a description about the question, the problem statement just now. Okay, this dynamic visual demonstrates the practical application of vector mathematics in real-world visual effects. The precise geometry and light interaction of the energy shield are controlled by vectors, and with normal vectors being key to defining its surface orientation and how light reflects off it in a 3D scene. This allows the sheet to shimmer and reflect text realistically, bringing complex mathematical concepts to life on screen. So on the right, it is a figure or an image that represent the problem statement just now. So we can see there is a character or superhero and holding a shield. So we can say the arrow is a normal vector, or maybe it's a ray or laser, and they have been attacked to him. Okay, next we see the solution for the question. Okay, for part A, we are required to find the vector equation using the given formula. So the general formula equation of plane uses the dot product between the normal vector and the difference between position vectors. So the formula is given that n multiplied by r minus r naught equal to 0. When n is the normal vector, r is any point on the plane, and r naught is a known point on the plane. So r naught is any point, okay, which means that we use p equal to x, y, and z. And step 2, we substitute the values. Okay, the given normal vector is n equal to 3, 5, negative 1, and the sheet center is a equal to 4, negative 2, and 3. So we just substitute for n and the r naught. R naught is the given unknown point on the plane. Okay, and then we answer the question, why normal vectors matter for lighting, which means why the developer or the designer use normal vector for lighting. The normal vector is crucial because the angle of light hitting the shade is calculated relative to the normal. This follows the fundamental optical principle, which means angle of incidence equal to angle of reflection. The GPU uses this relationship to determine how light bounces off the shade surface, creating realistic reflections and shimmering effects. So, the normal vector we use to make the reflection on the shade. So when we see the normal vector, we can measure the angle of the reflection of the laser. It also helps the designer to make a shimmering effects, or maybe a spark nearby the laser or the attack. Okay, next for the solution of part B, we transform into the scalar equation. The scalar equation expands the vector equation by distributing the dot product across each component. This form is more practical for computation. Okay, we're starting with the formula. Okay, the scalar formula is A multiplied by x minus x naught plus B multiplied by y minus y naught plus C multiplied by z minus z naught equal to 0. So A, B, C are components of the normal vector, and x naught, y naught, and z naught is the known point. Known point that we stated just now is about the center of the shape, which means point A. After that, we substitute the components. We insert A equal to 3, B equal to 5, C equal to negative 1, x naught equal to 4, y naught equal to -2, and z naught equal to 3. Okay, and then we simplify the signs. Okay, we simplify the signs. We handed the number negative for the y term. So for the last solution, we will get 3 multiplied by x minus 4 plus 5 multiplied y plus 2 minus 1 plus minus 1 multiplied by z minus 3 equal to 0. So this scalar equation represents the same plane as the vector form, but it's more convenient for algebraic manipulation and GPU processing. So it is the same with vector form, but it is in another equation that we have been simplified and expand from vector form, and it is more convenient for the GPU to process. Okay, next we move to the solution of part C. We convert the solution from part 2. We convert the solution or the answer from part B into the Cartesian form, which means from scalar equation into Cartesian equation. So the general Cartesian form is ax plus by plus cz equal to d. Okay, it's used by graphics processing units, GPUs, for rendering surfaces. This form eliminates parentheses and consolidates all terms on one side of the equation. So first, we expand the terms. Okay, from the scalar equation from part B, we will expand and we get 3x minus 12 plus 5y plus 10 minus z plus 3 equal to 0. So we combine the constants, okay, and then we will get 3x plus 5y minus z plus 1 equal to 0. And we let the final form by moving the constant to the other side for standard form. Okay, and we get 3x plus 5y minus z equal to -1. This is the formula the GPU will use to render the shear. Cartesian form allows the graphics card to quickly test whether any given point lies on the sheet surfaces by simply plugging coordinates into the left side and checking if the result equals to -1. Okay, for part D, it is the testing point. Okay, we have the location, the spark effect at Q 507. Okay, we substitute the coordinate of Q into the Cartesian equation for part C. So we multiply 3 with 5 plus 5 multiplied 0 minus 7, and we will get 8. So after, okay, when we compare the required value from part C to part D, 8 is not equal to -1. So the conclusion is the spark at the coordinate Q 507 is not touching the energy sheet because the equation does not balance. So which means the location of Q is not on any surfaces, okay, of the energy shield because the value is not equal to -1. Okay, and next we have another testing point, which means to find the z coordinate. Okay, the artist want to scratch detail at x minus 2 and x equal to 2 and y equal to 1. Okay, we substitute both of them in the equation. Okay, 3 multiplied by 2 plus 5 multiplied by 1 negative z equal to -1. And then we simplify and we'll get z equal to 12. So the scratch detail should be placed at z equal to 12. So the point of the scratch details is 2, 1 and 12 on the sheet surface. So as the conclusion, is bridging theory and practice, okay, in alignment with the big idea that mathematical tools provide powerful ways to interpret, optimize and solve real-world problems. Vectors serve as the essential bridge between abstract theory and practical application. By using normal vectors and Cartesian equation, we can interpret complex 3D environment, whether calculating pressure on a deep sea hatch, determining drone landing platform heights, or simulating light reflections on a CGI field, CGI sheet. These mathematical tools allow us to optimize solutions by ensuring structural safety and computational efficiency, proving that mastery of vector geometry is not just an academic exercise, but a, a vital capacity for addressing engineering and technological challenges of the 21st century. So, to sum up, the the conclusion is about the vector it's not just a theory that we learn, but it's how we use the application, whether in digital or physical. So in this presentation, it's about how we use the normal vector and Cartesian equations in digital world. So we use it as a to interpret the complex 3D environments and simulating the light reflection on CGI field. And this is some of the references that I use for research and making my writing and my presentation. So that's all from me. Thank you.